So in this video, we're going to be talking about this idea of a linear approximation even more. So we briefly went over what it means in the last video, and we also used something called the tangent line method in that video, and I'd recommend you check that out if you don't remember what it is. But in this video, we're going to be using a different method to do a linear approximation, something called a differential. And a differential is of the form dy equals f prime of x dx, right? So if you have, the idea is that if you have some change, in x, right, and you multiply that to the derivative, you can find that change in y. Right? And as we'll see in just a second, we can use this to help approximate the values of some functions at points where it may not be readily apparent. So going back to this same function that we talked about in the previous video, we're going to try to approximate the value of x equals 1.2. We're going to try to find the square root of x equals 1.2. Again, that's not something we know off the top of our heads, so therefore we're going to need a linear approximation. Okay, so let's do a little bit of drawing here. So we know that the form of the differential is as follows, right? So dy equals f prime of x dx. Okay, so we have some change in x here between, so for f of x, okay, for f of x, we have some change in x between x equals 1 and x equals 1.2, right? We have some delta x. Now, we also have some delta y between f of 1 and f of 1.2. We have some delta y. This is just basic stuff, right? Because if you were to take a line between these 2 points, you would know that this would be the run, this would be the rise, and this would be the run. It's just basic algebra again. Now here's the interesting thing. If we know delta y, we can figure out f of 1.2. Now, how would we do that? Well, it's pretty straightforward. So if we take f of 1.2, so f of 1.2 can be calculated by taking f of 1 and tagging on that delta y. And this is very intuitive, right? Because if you know a starting point and you know a change, you can figure out the final point. Now, unfortunately, we don't know what delta y is. That's an unknown value. We don't know what it is. So we're going to need to find some way to kind of guesstimate how or what that value is so we can add it over there. Okay? Now, here's something cool. Here's the tangent line. Which tangent line to x equals 1, right? So you've got a tangent line there at x equals 1. Now, for the tangent line, you can evaluate this tangent line. It's just a function at that point x equals 1.2. It's not a tangent line to the point x equals 1.2, but it's still a function at x equals 1.2. You get what I mean? I hope you get what I mean there. So between x equals 1 and x equals 1.2, that tangent line also moves some distance dx. It also climbs some distance dy. Okay? So we're climbing that distance dy for every dx we move. And again, that's the same concept of rise over run. If we have a slope dy dx, we're going to rise this much and run that much. That's just the idea. Now here's the thing. Let's use a different color. Notice how close dy and delta y are. There's a very small margin of error between those two. There's a margin of error for sure, but it's really small. Okay, So therefore, what we're going to say is, and this is going to be huge, for points close to x equals 1, we can say that dy is just about equal to delta y. Okay? That's the main idea here. And how do we find that dy? Well, we go back there, right? We'd say that dy equals f prime of x dx. Notice that f prime of x is a slope, right? It's a slope. And if you move some distance, if you multiply some distance in the x direction by a slope, you're going to get a change in y, a height, right? So that's basically where this is coming from. And so therefore, because of all of this, we can make the following final assertion. We can say that f of 1.2, oops, sorry, that's not f prime. We can say that f of 1.2 equals f of 1. Why do I keep saying f prime? It should be f of 1 plus dy. And if we do a little bit of simplification, we can say f of 1 plus f prime of x dx. Okay. Sorry, that's a bit messy, but that's where we're coming from, okay? So a quick summary. We know that for this function, between the points x and x equals 1 and x equals 1.2, the function rises a certain value delta y. So a quick summary. We know that for this function y equals square root of x, between between x equals 1 and x equals 1.2, it rises a certain value dy, delta y, okay? Now, if we know delta y, we can figure out f of 1.2, right? Because we take our f of 1, which is a known value by definition, and we can just tag on that delta y and figure out how far it's risen, okay? However, we don't know delta y exactly. So therefore, we're taking advantage of this tangent line, and we're taking advantage of the fact that because the tangent line goes so close to x equals 1.2, we can say that delta y is pretty much the same thing as dy for points close to x equals 1, and x equals 1.2 is. So for points close to x equals 1, we can say that dy is going to be roughly the same as delta y, okay? And then, how do we find dy? Well, we use the derivative. We say dy equals f prime of x dx. And then once we have that, we can just say that f of 1.2 is going to be f of 1 plus dy. So that's where we're coming from here. And now let's go ahead and solve this. So here we go. Before we go any further, let's just write out the equation that we're going to use. So we're going to say that f of 1.2 equals f of 1 plus f prime of 1 times dx. So given this equation, we can start doing some things now. So f of 1 is simply the square root of 1, which is equal to 1. Okay. Next we have f prime of 1, which is simply the derivative of square root of x evaluated at x equals 1, which is 1/2 x to the negative 1/2 evaluated at x equals 1. And I know that I did that pretty quickly, but honestly that's one you should know by now, given the power rule and stuff like that. And this is just going to be 1/2. Now dx, that last thing, is simply the difference between x equals 1 and x equals 1.2, and for that reason it's just going to be 0.2, right? Now we have all the pieces we need. Let's just go ahead and solve. So f of 1.2, let's pull this down here. F of 1.2 is going to be equal to 1 plus, what's f prime of 1? That's going to be 1/2 times 0.2. Okay, and now if we were to plug that, if we were to just go ahead and evaluate that, that should be just about 1.1. Now the true value for the square root of 1.2 is in fact, so the true value of the square root of 1.2 is in fact 1.09544 yada yada yada. That's the true value. Okay, and as you can see, these two things are again pretty darn close. They're pretty darn close. So therefore we can say that this was a pretty good approximation. Again, just like the tangent line method, this is also a really good way to approximate the value of the function at that one point there. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time!